Hani came to this project slightly after the beginning because I didn't know him at all. I had seen some of his work actually in Wired, and called him and went to see him in New York. And it's his work as an architect and information architect falls somewhere between the printed page and interactivity on the web. I don't know what that was.
Oh, that must be
Something going to land on my head and squash me? Some sort of power surge, huh? Is everything okay up there? Huh? Okay. Somehow I think in his work is a look at what might be happening in information architecture, of how we're going to create graphics that truly are fast, instant, and changeable and interactive right away. So, Hani.
Thank you very much, Richard. Thanks very much. I have a bit of a cold, so excuse me if you don't hear everything I'm trying to articulate. I have a firm, a practice with my partner, Lisanne Couture. We also have a 3-year-old, which I miss very much now after the last talk, in New York City. Our practice is called Asymptote. We chose the name Asymptote quite a few years ago when we started in 88, 89, because as a mathematical term, it's the coming together of two parallel lines meeting at the vanishing point, meeting at infinite space. And we thought that was a pretty good model for theory and practice, and the idea to have an architectural practice that would, in fact, be the merging or the convergence of theory and practice. Well, in 1994, while I was teaching at Columbia University, where I still teach in the architecture department, I went up to the dean one day and I said, I really could use a computer, maybe just one, a Mac or something up in the studios with my students and perhaps...
I always like to tell the
Sure.
audience what's happening. There's nothing to worry about. They just turn the air conditioning on, and that was the sound of that, okay? Okay, fine. Sorry to interrupt.
No problem.
Okay.
So that blossomed into what we started in '94 at Columbia called the Paperless Studios, which, thanks to Macintosh and to SGI, became very, very robust in the amount of equipment we had. But then the question came to me what to teach and how to teach with a computer and how to actually enter the problem of the digital condition within architectural practice. And my graduate work, I won't bore you with the whole thesis, but I studied in depth Camillo's memory theater. Giulio Camillo was a 16th century military engineer, architect, who built a theater of memory for the King of France as a commission. And the king had said, I want a place that I can go into and acquire all knowledge, all things, open drawers, pull levers, and discover and know all about the cosmos. That really intrigued me. I ended up, under my teacher in graduate school, trying to rebuild the Camillo Memory Theater, which was destroyed and nobody really knows what it ever looked like. So years later, I'm finding myself starting to teach architecture through the computer, and I realized that we have the memory theater, we have the computer, we have this incredible infinite window into information. And when I put a computer in our office, I remember the first two things that happened, and they're kind of important for the work I'm going to show. First thing was that I ended up staring at this, what looked like a broken egg on the screen for a long, long time. And one of the people working in my office walked by me and said, what are you doing? And I said, well, look at this. This image is an image of, it's live, a 20-minute delayed image from the Hubble telescope of a quasar or a black hole or some incredibly sort of interesting phenomena in outer space, in our cosmos. And I just can't help, and it just became this remarkable thing to stare at, which said to me that this window into information and into the cosmos is something we've been after for a long, long time. And it brought to mind, and I think one of the proto-Tedsters, if you will, was St. Augustine, who said that we are in the universe, or we are in the cosmos, as dogs are in the library, that we meander around sniffing, but we just don't know how to get all that information. We just don't know how to understand what it is we're inside. So with that in mind, I started teaching paperless studios, and I turned to, and I want to dedicate this talk a little bit to Muriel Cooper, because I turned to Muriel Cooper's work, who I believe presented at TED a few years before, and was fascinated with this MIT Media Lab experiment in spatializing data. I thought that's maybe where architects should start to think about working if we work in digital media. Can we, in fact, spatialize phenomena, data, information? And that's how that work started, or that facet of my work started at Columbia. So with that in mind, I'm going to show you a few projects, 2 projects in particular, one which we are about to launch on the internet, and one that is in fact running now down on the trading floor, stock exchange trading floor. Could you just take these lights down to give as much image to the screen as we can get? The practice meanders around. We design buildings, we design urban plans, we are designing work at the moment in terms of office environments. And in particular, though, today I'm just going to show you these 2 projects. The New York Stock Exchange came to us and said, we have an immense amount of data, obviously, that we use every day and that we need to navigate through. And can you help us? They asked us if we could help them produce a virtual environment in which this data could be navigated, understood, correlated, and really just kind of comprehended. Again, the memory theater. I thought, well, we'll start working on it and we'll see what we can get. Now, they had done a lot of R&D in the situation and worked with all kinds of interesting and compelling kind of groups, but they'd never decided. The thought of going to an architect was something very foreign to them, and in fact it was kind of a lark or kind of a risk. They heard about some of the work I was doing at Columbia and thought maybe that we could help them with this situation. As what you're seeing here is just the rudimentary wireframe model of the virtual trading floor as we started to model it later in this process. And what's in the background, in fact, are all the server systemscapes that are here. So what is now separated into 2 different locales outside of New York for reasons of terrorism and other reasons, we've consolidated here, which is hundreds of servers that run the exchange in one environment that can be approached, navigated, and understood in a multidimensional way. So the virtual trading floor model itself, which now runs in real time on the trading floor off of 2 large reality engine silicon graphic machines, is in fact a kind of mock or sort of a mimicking of the existing floor. That circuit board that just disappeared, and allows me to pull out different drawers with different server landscapes in there. There you see the circuit board again, which connects all the servers down to the actual trading floor, and you can see where stocks are being affected by system errors or system conditions. On the actual virtual trading floor, these are the posts. They're all geographically true to where they are located in the real floor, but idealized and kind of virtualized in this model. The walls are made up of tickers of data, live television feeds, recorded feeds, news data items, and that entire kind of virtual wallpaper can be toggled by the users to contain any kind of information they see necessary to be traversing the virtual floor as they navigate it and look at the data on it. The model is used in all kinds of different ways. We're just flying here through an opening in the morning of the stocks. They're turning yellow to green to normal as they open, so one can see immediately all the stocks that are opening on the trading floor. And if there's any problems, they can be alerted quickly. These are virtual thermometers. We invented these little things, or developed these little things as ways to actually take the kind of health of the post, and they're able to be read very quickly by the operations people in terms of how particular posts are doing. Also embedded in the trading floor are different kinds of containers holding different kinds of data that can be all sort of retrieved from the model and pulled up on separate screens to be studied and analyzed separately. This is post number 2. In post number 2, in its kind of default rotation, you can see that there's a red kind of lock on. That has a timeline on it, which is being sort of diminishing here in time according to the amount of time it takes to repair the problem. If we zoom in on it, you can see that there's a Dow stock here, McDonald's, which is affected by this problem. Once the problem is resolved, they go back to normal, and we can continue to drill down inside this virtual post sort of infinitely, getting more and more information concerning that particular stock. We can look at these posts from different points of view, different angles, as much as we would look at any kind of architectural or any object. We can split screens into a number of different views, study different parameters, even study sort of replays on the same post or the same condition to, in fact, go over data, go over problems, and analyze what, in fact, brought about any particular condition. This is what we call a heat map. It's a floor piece under the posts that contain the actual books of stocks, which has its own kind of multidimensional map that's moving in real time. And here is a sort of view of one of those books with particular stocks on them. You know, as architects, finding ourselves developing multidimensional realities, I guess, or virtual realities, and then dealing with interface issues, and using, in fact, architectural kind of paradigms to help understand and navigate dimensional space. For example, here's a 2D map that allows you to move the model in a 3D, around a 3D model with a kind of dashboard condition below that allows you to move around inside of that. We developed a whole series of iconography here for the flags that come up. Hold on, let me play that again, sorry. The iconography here is based on nautical maps, nautical diagrams, so you can quickly understand this is order imbalance, trading down, and so on, order cues. And these flags are very, very quick and obvious to read by the users. Here are two DAOs, AOL and IBM, that are being looked at for a problem. One can bring a HUD up, a heads-up display, to see what, in fact, the problem is in 2D by using the zoomable interface or the heads-up interface. And they get all kinds of information here on AOL, for example. Make that the primary sort of perceptual thing on the interface, and allow the 3D model to be there as a kind of a ongoing sort of reality mechanism in terms of what's actually going on with that particular place. One of the things that became fascinating to the New York Stock Exchange when we produced the project and began to demo it and use it with them were things like the fact that they could replay data, replay reality, replay their reality. This is a rewind of a day's events looking at 4 variables: the Dow Jones Industrial Average, Transportation Average, S&P 500, and the New York Stock Exchange volume. And one can pull out different aspects of that and study it according to other aspects. So the correlation possibilities in a multidimensional environment are pretty rich and are being very much appreciated by them in the way they're using this now. This is a grouping container. It's a container that allows the stock exchange to put in any corresponding group of stocks. This happens to be Dow 30. One can put in tobacco-related, monetary-related, technology-related, and study them separately as virtual models. Pull up any aspect of that, in this case the order velocity, and then bring those things down into these little displays. This is Caterpillar, obviously, in Procter & Gamble, and one can see now how the iconography becomes a way to read this information in 2D. I'll just skip through a couple of these, so I know we're under time constraint here. We're also developing now virtual, these are traders' booths. We're also doing a kind of pervasive stock exchange project with them now, looking at interfaces ranging from this one, which is running off of very robust machines, to internet projects as well as PDAs and so on. And in many ways, I think it is giving a kind of it's a tool that is keeping up with the technological leaps and bounds that are being made, which in fact is necessary to safeguard this kind of immense sort of thing called the stock exchange in its real and virtual state. This is in fact an example of a working drawings that we sent out to our programmers in Tel Aviv. They happen to be in Tel Aviv, and they would wire back the models to us, which would then get implemented down on the trading floor. That's the model today. It's actually known, it's the model of the previous iteration. And the interface itself is really a kind of key component of the project. We looked at ways in which we could tile a number of screens and create a sort of array of data that can be gotten to, retrieved, replayed, and worked with in a single situation in terms of zoomable screens, movable entities, following different aspects at the same time. These are just some views down on the virtual trading floor. This is the image that Wired published. It's one that is very much, it's actually a camera taken down on the virtual floor as it's in fact, these are the index containers down here. the grouping containers in the background, the walls, and so on. And there is now discussion, and it's interesting how this virtual space is becoming a very real space for the New York Stock Exchange. And there's a lot of talk about getting camera feeds in on the virtual model and using those throughout the data. In fact, show what's going on there. This is another one of our favorite views from under the trading floor of the circuit board. And here's a view from above with and we built a facility for them down on the trading floor where they navigate this data on these 9 25-inch flat screens. They also have 60 other flat screens here that are fed through conduits. We designed this so that each of these could just be tiled on. The irony is they don't have much use for these 60 screens anymore. They did it as kind of a backup plan, fearing that the 3D model may not satisfy their needs. And in fact, it's become, I think there's an analog clock running on this one now, which is pretty amusing. Anyway, let me move on then to the other project I want to show you. This is the first time I'm showing this in public. It hasn't been put online yet. I thought it would be something that I should do because I know the history of these conferences, and I'm feel very privileged to be able to speak here. So I thought that I would just show you the virtual museum for the Guggenheim that we've developed with the Guggenheim. They, having done the Bilbao in first reality space, I guess it's a hard project to trump in first reality architecture, but in virtual architecture, it's kind of open field. And when they came to us, they said, we're collecting a great deal of digital art and digitally generated art and internet-related art, and how can we house that? It seems that white-walled, these were some young curators there who came to us and said, white-walled, kind of static, monolithic building isn't necessarily the place that we want to show the art of the 21st century as it's beginning to emerge. And we don't even know what that art's going to be like. It's only beginning to emerge. So we developed this project, which essentially is not so much a web environment as it is an attempt to create a virtual architecture ported over the web that you'll be able to use and use often and stay with and kind of visit the way you would visit a building. The first premise is that you actually have control over a morph, and that morph, in fact, is a control over a kind of band that's surveying a landscape, surveying a terrain, surveying a topography. And on that topography, you have all kinds of potential places to visit. So, for example, here I can go to the cyber theaters, the archives, the artist zones, artscape area. I won't explain them all. Media sphere, education zone, kind of children's museum here, a virtual architecture gallery where we're going to put our TEDx work in, if they'll let us curate part of that. Because we did do some work for that, which I could show. Also, and so on. And so these go into three phases of approach. And phase one is kind of the McLuhan-esque idea of moving from an old medium into a new medium. One has to quote the old medium. And I think moving from analog or first reality architecture to virtual architecture, we decided to quote first reality architecture. So this is actually a kind of interpretation, let's say, of the range of architectural history embedded in the Guggenheim from Frank Lloyd Wright to Frank Gehry, and even including Venice and Peggy Guggenheim collection. And let's say we want to now, and I'll just take you through this quickly. Richard, cut me off whenever you want. Here we go into the virtual museum. I can rotate around this object as a piece of architecture, and that's effectively, and I can get to know this object, this being the first one, the plaza, from all kinds of different points of view, from the plaza view, the atrium view, the public affairs view. And this really started just from a kind of a fantasy that, Bilbao is terrific, but if I could rotate Bilbao and go in wherever I want, I think I'd like the building a little better. So that's how this all started. Here's the atrium, for example, and I'm going to go into the atrium. This is all running on the web. This is this is all working with current web softwares, current web protocols. Its possibilities with the more broadband capabilities, I think, are quite interesting. We're now inside a kind of virtual atrium where I can move around in there, read this kind of Jenny Holzer-like text. I can see other aspects in the distance beyond the plaza, there's the galleries. I get to know these things after all, but those are the galleries in the background, the venues, and so on. I can also go in as a VRML model. And part of the thinking there is that my 3-year-old, who's been on a computer since he was 2, is incredibly savvy at using a computer. And I think that, in a way, this is being designed for our generation. But the thought that with broadband capabilities and full three-dimensional interactivity on the internet, I don't think it's a stretch to be able to imagine a world where moving in 3D is just absolutely normal. This is a VRML model, a VRML model, which I can actually manipulate any way I want to look at from any point of view. And we've done it in such a way that it actually, let me just zoom out here. As we move around it, I can go to preset places like the roof of it. I can go to the atrium area again, fly in there. Or more importantly, the cybermedia wall. And the cybermedia wall is the place where I can see the announcement of the shows. And since this is going online very soon, there's a Nam June Paik show that's on now, as well as some other shows that I could sort of zip around here and see what they are. If I go to the venues area, and again I can go into this area either through the VRML or the Flash medium. I can go to Berlin from here, I can go to Bilbao from here. If I go to Bilbao, I basically now fly into that model. And the thinking here is that the paradigm for the web should not necessarily be photographs, still images, or magazine clippings. It should really, we think it comes out of the medium of film and the medium of moving interactive imaging. And so that idea is actually that you can actually go into a cinematic, let me go back to another place, let me go to New York for example, that you go into a cinematic experience, that you actually, and I believe this very firmly, and I do this with my students. I always tell my students in architecture school, I say we don't move through space with our heads in one position, looking right and left and moving forward. We exist in space in an incredibly multivalent, hypertextual manner. We notice things out the periphery of our vision, we move around freely, we hear conversations, inadvertencies come into play. So all of that chance mechanism is part of what we're trying to feed into this thing. So if I were to go, let's say, to the New York aspect of this, it's the same thing. I go into the virtual model and I find myself in a kind of cinematic experience of the New York Guggenheim. From here, we'll be able to click in, and we don't have it on this model, into live cams. I'm out of here. Into live cams. Let me just show one thing. You'll like this one. In the galleries, let me just show you one of the artists at least. Who do you want to see? In the galleries, we have things like Kandinsky, online art, Matthew Barney, and so on. I'll take you to Matthew Barney, just so you've at least visited one artist in the virtual museum. We go into what we call a Barney blob. This is the Barney blob. And it then reveals itself as some of Matthew Barney's work. Well, thank you very much. Once I'm in there, I continue in, and now I go into a virtual gallery. I go into Matthew Barney's work, put into a VRML model. Thinking there is that once you start to house artists' works in multidimensional space, they have entirely different readings than walking in a static room looking at pictures on a wall. I can basically move around inside this thing and look at the various pictures and click on different aspects, and I won't do it now, and go to different movies and so on. Or I can just sort of retrieve this object. I can just sort of keep my Matthew Barney memento and sort of move in and out of it and keep it somewhere else and kind of collect the art. And part of that thinking is that we're doing a part of this virtual museum where you can start to curate your own work and produce your own kind of virtual museum, which would keep your IP address on file, and as you come in every time, you would continue to visit and inhabit and locate yourself in it. Other things we're looking at, things like being able to tabulate how many people are online at any given time, chat bots, all kinds of other stuff. But that's it for now. Thank you very much.